dear students, this is Mr Ahmed, your maths teacher. Today we'll be learning number 6 and algebra. In algebra we'll be doing some simultaneous equations. So first of all we'll be looking at number 6. Under number 6, the rules of indices. See here, when you multiply the indices, when you multiply the powers, see here the indices a to the power 2 times a to the power 3, these 2 and the 3 would be added, and therefore the answer would be coming 5. So a to the power 2 times, so multiply by a to the power 3. If so, a 2 plus 3 is equal to 5. The answer, the product is a to the power 5. Meantime, when you divide the indices, the indices would be, the a would remains the same, but the indices would be subtracted. 5 minus 3 becomes 2, a to the power 2. Suppose you are going to divide 3 to the power 5 minus 3 to the power 3, the answer would be 3 to the power 5 minus 3, therefore 3 to the power 2. 3 to the power 2 is 3 squared, therefore you will be getting the answer 9. See here, when you raise the power to an existing power, when you raise power to an existing indices, these two, the indice and the power, would be multiplied together. 4 times 2, a to the power 4 times 2, therefore the answer comes as a to the power 8. Now we'll move on to the next slide. So here we'll be looking at direct proportion and inverse proportion. Direct proportion, check here, if two quantities are in proportion, then when one is multiplied or divided by a number, so is the other. Just say I'm going to buy one chocolate which costs 2 pounds. Okay, check here, I'm going to buy one chocolate which costs 2 pounds, and I'm asking you a question: if I buy 5 such chocolates, how much should I pay for the shopkeeper? See here, in this case, if one chocolate cost $2, how much 5 chocolates cost? See here, one cost $2 mean 1 times 2. Therefore, we have to multiply that 5 chocolates also by that 2. Then finally we'll be getting the answer. 5 times 2 would be $10. See here, this kind of relationship is called as direct proportion. It means when one increases, the other one also increases. Then we'll move on to the inversely proportion. Inversely proportion mean when two quantities are multiplied together, the answer is always the same. I mean the product is always the same. It means the product remains the same, one quantity increases, the other decreases. The perfect example of this is the Boyle's law. I hope you all might have heard about the Boyle's law. Boyle's law mean when the pressure increases, the volume decreases. For a certain mass and a certain temperature, when you increase the pressure, just take a certain volume of a container. If you squeeze the container, when you squeeze the container, you are applying more pressure. When the pressure increases, the volume would be decreasing. This kind of relationship is called as inversely proportion. Right? That's the idea about direct and inversely proportion. We'll move on to the next slide. Fractional indices. So this one you have to be a bit careful, because we're going to deal with all indices which you have already learned, but we're going to learn something new here. See, 4 to the power half. 4 to the power half. It's not only one power, say there's one number divided by another number, but both altogether you have to consider as one indices. 4 to the power half multiplied by 4 to the power half. See, the bases are same. Here also the base is same, base is 4, and here the base is 4. So when the bases are same, and if they are multiplied, the indices would be added. Therefore, 4 to the power half plus another half. Half plus half equals to 1. Therefore, 4 to the power 1, that equals to 4. Now see here, the way how we get 4, just say, if I'm asking you what's the square root of 25, you will be saying 5. Means a number which multiplied by itself gives a product. That means that's the square root. Now see here, won't it be the 4 to the power half multiplied by the same number itself and gives 4? Yes. So 4 to the power half should be the square root of 4. Now see here, I can explain you in another way. It's very obvious for us, square root of 4 times square root of 4. As I said, 5 times 5 is equal to 25. Just say square root of 4 times square root of 4 is equal to 4. Therefore, we can say, can you see the similarity between this and this? The same thing multiplied by itself and gives the product 4. Therefore, we can say this 4 to the power half is equal to the square root. Now see here, hereafter we can say instead of the square root, just say if I am giving a number square root of 2, you can even say 2 to the power half. That means that's also equals to the square root. That we can see here. This means, this particular elaboration on top means that 4 to the power half is equal to square root of 4. That means in number it's equal to 4. It's equals to 2. So 4 to the power half means the square root of 4. Therefore, we're going to check another example, a similar type of example for that. Similarly, I'm going to take 8 to the power 1/3. 8 to the power 1/3 times 8 to the power 1/3 times 8 to the power 1/3. Okay? So we just before we have learned when with the same base, if there are any indices multiplied, the indices would be added. So we'll do that. 8, 8, 8, same bases. So the indices would be the indices would be added. So 1/3 plus 1/3 plus 1/3. 8 to the power 1/3, 1/3, 1/3. All the denominators here are same, 3, 3, 3. So we can keep the common denominator 3. So the numerators would be added 1 plus 1 plus 1, it's equal to 3. 3 divided by 3 is equal to 1. Therefore, 8 to the power 1 is equal to 8. Now, we can compare this one with this. This means that 8 to the power 1/3, 8 to the power 1/3, the same thing, the same set, the same portion is being multiplied 3 times. Therefore, we can say 8 cube root, that is equals to 2. So 8 to the power 1/3 means the cube root of 8. We can even practice some more with just say 1/4. 1/4 times 1/4, there will be 4 times continuous digits would be coming. Therefore, we can say that is the 4th root of that. And I think this is time for us to do some exercises in this topic, what we have learned. See here, 27 divided by 8 to the power 2/3. What we gain, what knowledge we have gained in this lesson, we are going to apply. See here, 27 divided by 8. How can I write the 27 as an indices? Just check. Am I supposed to write 3 to the power 3? Is it correct? Or am I supposed to write as a power of 2? Just check. Shall I write it by with the power of 2? It's impossible. So I'm going to take 3. 3 to the power 1 is 3, 3 to the power 2 is 9, and 3 to the power 3 is 27. Therefore, I can write 3 to the power 3 divided by 8. I can write as 2 times 2 times 2. Therefore, 2 to the power 3. Altogether, I can write this common indices 2 divided by 3. Now check, since this 3 is the common power, is the common indices, we can write 3 divided by 2. I'm going to write this 3 on top of this, since this 3 is common for 3 and 2. Now see here, if I keep the 3 here, this one would appear here. Since we have learned the rules of indices, the third rule of indices is when you raise the power, those would be multiplied each other. This 3 would be multiplied by 2/3. This 3 would be multiplied by 2/3. Therefore, 3 times 2/3, this 3 and this 3 cuts off. There would be an answer, 2 remains. Since the answer 2 remains, we can write 3/2 to the power 2. Then now see here, 3 squared is 9 and 2 squared is 4. Therefore, we can get a fraction for this answer. And now, I hope you are clear with this, and we can go to the other one. Yeah, now I think this is the time for us to apply what we have learned so far. I'm going to do some workouts for you. You can check it carefully. The first one, 27 divided by 8 to the power 2/3. So check here, I'm going to write 27 divided by 8 to the power 2/3. Now see here, this 27 I'm supposed to write as a power of something. It would be better if I write it as a power 3, because you know, if the 3 comes here, we can easily cut and chop. So therefore I have to choose a number which is common for this one and this one. We can simply write 27 as 3 cube and the 8 as 2 cube. Since 3 times 3 times 3 is equal to 27 and 2 times 2 times 2 is equal to 8. Therefore, I can write it 2 upon 3. Since the 3, this 3 and this 3 are common for 3 and 2, I can take this 3 out and write it like this. Write it like this. 3 divided by 2 to the power 3, and since this 2 upon 3 is left, I can write it all together the power 2/3. Now see here, this is the time for us to apply our third rule, which is when raising to the power which was existing earlier, that would be multiplied by the latest power. Therefore, 3 divided by 2 into 3 multiplied by 2/3. Therefore, this 3 and this 3 cuts off, only this 2 remains. I can write it, this 2 I can write it, 3 divided by 2 to the power 2. Therefore, the answer 3 squared is 9 and 2 squared is 4. And 9 upon 4 would be the final answer for this question. Just check, my dear students, the steps, what I did and how I came to the end of the question. And we can try the second one also. First of all, I'm going to give you some time, a little time, for you to check the second question. What idea when you see this half comes? Whenever you see the power comes as half, it directly means the square root. In the sense, 16 square root is 4, 25 square root is 5. So directly you can get the answer 4 upon 5. 4 upon 5 would be the answer. And I think we can come back to the third question. 4 to the power 2/3 divide by 2 to the power 1/3. 2 to the power 1/3. Since here 2 and here 4, it's better for us to take this one in the base of 2. So I'm going to write 2 to the power 2. This 4 I'm supposed to write as 2 to the power 2. So see here, 2 to the power 2 multiplied by 2 upon 3 divide by 2 upon 1/3. Check it carefully. What are we supposed to do here? Since this is raised to power, we have raised the power over here, this would be multiplied by this. Since we don't have any choices to cut and chop, we can straight away multiply 2 times 2, 4, 4 upon 3. So 2 to the power 4 upon 3 divide by 2 to the power 1 upon 3. 2 to the power 4/3 divided by 2 to the power 1/3. Therefore, since the bases are same, the powers, the indices would be subtracted when it divided. So 2 to the power, we can write 4/3 minus 1/3. Therefore, the answer 2 to the power, sorry for that. Therefore, the answer 2 to the power 3. 4 minus 1 is 3. 3 divided by 3. Since 3 and 3 are common denominators, we can subtract the numerators 4 minus 1. We can get the answer 3 upon 3. So 3 divided by 3 would present 1. The answer is 2 to the power 1 is equal to 2. So I hope this one gives you a clear picture about the division. When you divide with the same base, you have to subtract the indices. Have a look on this, and then finally we'll move on to the last question. Our last question is 3 to the power 1/3. 3 to the power 1/3 multiplied by 9 to the power 9 to the power 1/3. Ultimately, the same rules applies. Whenever you see some similar numbers, you're going to write with the same base. So here 3 to the power 1/3 remains the same, multiplied by this 9. I'm supposed to write as 3 to the power 2. So I'm going to write 3 to the power 2 into 1/3. Therefore, 3 to the power 1/3 multiplied by 3 to the power 2 times 1, 2, 2 upon 3. So since the bases are same, okay, we're going to do the same work what we did for the previous questions. 3 to the power 1/3 multiplied by 2/3, both would be added. So 3, 1 upon 1 plus 2 is 3. So 3 upon 3 we can say 1. The answer is 3 to the power 1 is equal 3. So that we have taken a look at 4 questions in order to apply what we have learned, the rules of indices. All 3 rules of indices we have just checked in these all questions. Now it's time for us to move on to the next topic, the algebraic topic, simultaneous equations. Dear students, have a nice check on this. Since you need a rapid example, a basic foundation about simultaneous. Since you're starting now, check here. I'm going to give you a foundation. If you are writing an equation x plus 2 is equal 3, it's easy for you to find x since there is only one unknown term. See here, 2 is a number, a digit, 3 is a number, but x is only the unknown term. Therefore, we can very simply say logically x equals 1. So we don't have any problems in that. But here in this junction, x plus y is equal 6 and x minus y is equal 2. Since there are 2 unknown terms, we are not supposed to find what it is actually, because we can give some other values. If x plus y is equal 6 mean x may be 1, y may be 5, x may be 2, y may be 4. We don't have a fixed amount of answer for this. Therefore, we need a parallel equation like this. So like this equation, we have one equation here. Parallelly, we need another equation with the same terms, with the same unknown terms. Parallel, we do have another word called simultaneous. Okay, that's why we say simultaneous equations. When we are giving a simultaneous equation to this equation, we can do subtraction, addition, multiplication, division, and cut off one unknown term. We can eliminate or substitute and find the final answer. See here, I'm going to do an explanation. I'll do that one for you. Since here x, x, y, y, when you subtract x minus x, x minus x cuts off, it goes. That's also possible. There is also another way, plus y minus y. Just say plus something and minus something. If you add plus y plus minus y, those two eliminate. Those two cuts off. So I'm going to take this one as the first equation and this one as the second equation. So this is very careful nomenclature. I mean, when you are going to name the equation, if this is the first equation, you don't just put 1. You have to put it round. It means you don't have to write in alphabetic also. If it put a round, it directly means this is the first equation. Now see here, I'm going to add first equation with the second equation. All the elements, make sure all the elements are added, not only 1 or 2. X plus x. So x plus x, 2x. Now see here, 2x. All the elements from equation 1 would be added with equation 2. So y plus y, very carefully check. Then I'm going to write the symbol plus. Then I'm going to write, sorry for that. Then I'm going to write minus y. Very careful, you don't just write y, write the y with the symbol minus y. Then put the equal mark. Then see here, first one plus the second one, 6 plus 2. Check. Y plus bracket minus y. Y, I'm going to show it carefully. Now see here, this plus, when it multiplied by y, since there is a bracket, this plus would be multiplied by this minus. Therefore, plus into minus gives us minus. See here, 2x plus y minus y equal plus y minus y. Plus y minus y mean both of them cuts off, they goes is equal to 8. Just say plus you can think as the amount you have in your hand, minus mean the credit you have to give to somebody. Just say if you have 4 rupee in your hand and if you have to give somebody a credit 4 rupee, if you will be giving the credit 4 rupee to them, then therefore you won't have anything in your hand. This is the simple clarification on plus and minus. Therefore, 2x equal 8. If 2 chocolates equal to 8 rupee, 1 chocolate 4 rupees. This x is equal to 4 because one unknown term we have found. This x is equal to 4. We have to substitute in this first. This is your choice. We can choose this first equation or second equation. You apply this and find the value of y. I'm going to do it here. X. You have to write it in words. X equals 4. Substitute in, no need to write equation, just write, put a 1 and put a round over here. Then x plus y equals 6. Therefore, x is 4, 4 plus y, 6, y is equal 6 minus 4. If something is added in one side of the equation, just say these are two sides of the equation. One is left hand side and the other one is right hand side. If something is added from one side of the equation, that would be subtracted. If something is subtracted, that would be added. If something is multiplied, that would be divided. And something is divided, that would be multiplied. This one you have learned in your grade 8. Now see here, y is equal 6 minus 4, 2. Therefore, we got the solution, x is equal 4, y is equal 2. X equals 4, y is equal 2. This is the final summary of the answer. So we don't have to worry about, though they are going to give 2 unknown terms or 3 unknown terms, if they give parallelly, if they give simultaneously another equation, we can subtract or add and find the conclusion. And this is another type of question, almost similar but small, a little different question. We'll be doing this one as well. Now see here, 2x plus 4y is equal to 50, x plus y is equal to 20. These are our two equations, equation number 1 and equation number 2. Check here, in our previous question, we had 2 elements. Both the elements were same, therefore we can subtract. or therefore we can add and cut it off. But check here, if you subtract 2x minus x, there would be x remaining. If you add, that also x remaining. So this way also the same. So we can't do anything. Therefore, we can find another way. This second equation, just say, if you multiply the whole equation by a number, the equation won't be changing. Okay? According to that rule, we're going to check the entire second equation. The entire second equation, I'm going to multiply by 2, number 2. This means equation, this means, if there's no round off, it is the number 2. So I'm going to multiply this by 2. X times 2 is 2x plus y times 2 is 2y equals 20 times 2 is equal to 40. And this one I'm going to label as the third equation. Therefore you check first one and the third one. Now it's very simple for us. Here also 2x, here is also 2x. If you subtract, 2x would be cut off. So now, but make sure, be careful, just say it's better for you to subtract from the bigger number to the lower number rather than the lower to bigger. It's okay for you to subtract from the bigger to the lowest. Now see here, since the 50 and 4y are bigger, it's easy for us to subtract from the bigger to the smallest. So I'm going to do equation number 1 minus equation number 3. Okay, now very carefully understand, you don't have to think about this because the third equation is the modified equation of the second equation. Since the third equation is the modified equation of the second equation, you don't have to worry about that, just keep it as it is. Now 2x minus 2x, so that goes off, plus 4y minus y equals 50 minus 40. Now see here, 2x goes off, 4y minus y, it equals to 3y is equal to 10. If 3y is equal to 10, y is equal 10 divided by 3. Therefore the answer comes as 3.3 something. And this value, y is equal 10 upon 3, as we did in the previous question, we are going to substitute this value in either equation 1 or 2. Now check, when you add or subtract, you give the preference to the bigger number, bigger choice. But here, when you're going to substitute, you give the choice, give the priority to the lesser simple equation. See here, out of these 3 equations, the second one is the simpler equation. So therefore, we can substitute in the second equation. I'm going to do it here. Check. Y is equal 10 upon 3. See here, y equals 10 divided by 3, substitute in equation number 2. Now therefore, check here, x plus y equals 20. We know y is equal 10 upon 3, so x plus 10 divided by 3 is 20. Therefore x is equal 20 minus 10 third. 20 minus 10 third. So x is equal, we know 10 third is 3.33, and 20 minus 3.33 is equals to 16.66. So we can put 6, 7. This would be the answer. Then finally you check, x is equal 16.67 and y is equal 3.33. And this would be the final solution for us for this simultaneous question. And I hope you all understood the lesson, and I think this is the time for us to wind it up. Students, you stay home, you all be safe, God bless you.